Let's discuss the scope of lambda expressions. Scope is the area in which a variable is available. So for example, when we declare a variable inside a method, a local variable, this variable is only available inside that method. When we declare a variable at the class level, it can be accessed throughout the entire class. Unlike methods, lambdas share the scope of their enclosing environment. Therefore, you cannot use names for identifiers in lambdas that already exist in the closing context. Simply put, that means if I have an int x inside my method, I cannot call the input parameter of the lambda x as well, because that would result in a naming conflict. Lambdas can access fields and methods of their enclosing scope, but they can only access local variables if they are final or effectively final. I honestly quite like the term effectively final. It means that you could put final in front of the variable declaration and it would still compile. Okay, so lambda expressions share the scope of the enclosing environment. That means they don't have their own separate scope. And this has some important implications. Again, identifier names in lambdas cannot be the same as those in the enclosing scope. This is because having two identifiers with the same name in the same scope would cause ambiguity. Lambdas can access fields and methods from the enclosing scope, as they share the same scope. But lambdas can only access local variables from the enclosing scope if they are final or effectively final. This is because the compiler needs to ensure that the variable value does not change during the lambda's execution. Let's see an example in IntelliJ. Here we have the class lambda scope example. I'm going to give it a main method. Let's give this a local var 6. Like this. And then we can implement the calculator. And I can say, well, let's call them A and B this time, becomes A times B plus local var. And I can access this. Why? Well, it's because local var is effectively final. Let's create an int for result. I'm going to say calculator.calculates. And I'm going to pass in 3 and 5 again. And then let's print the result so we can actually see it. So if we run this, the result is going to be 21. It's going to 3 times 5 and then add 6. And this is allowed because local var is effectively final. Let's undo that and inspect the red squigglies. So I'm going to update local var to now be, 7. There we go. And you can see we get red squigglies. So I'm going to hover over them. And it's going to say variable used in lambda expression should be final or effectively final. There you have it. What we can also not do is, instead of A, call this local var. Why not? Well, because local var already exists in the outer scope. And it says local var is already defined in the scope. There you have it. Let's change this back. Likewise, we could also not call this A. That would result in the exact same problem. And also this one not being known, of course. But you can see here now that A is already defined in the scope. And alright, that's the last thing you need to know about lambda expressions for now. We can say that the rest is out of scope. I want to show the built-in functional interfaces in Java. And these play a central role in functional programming. So we'll have to know the built-in functional interfaces and be comfortable implementing these with lambda expressions before moving on to functional programming.